Before you decide to wire up a breaker panel and start typing how to wire a breaker panel into a YouTube search bar, or do any electrical work yourself, there are 3 things you need to have covered. First, know the basics. You should understand the basic concepts of voltage and current, AC electricity, the roles of live, neutral and earth, as well as the roles of each piece of equipment you are going to install. And of course, you need to understand that household electricity can be extremely dangerous. Second, you need to check if you're actually allowed to do the work. Here in France, you can generally do electrical work in your own home yourself, and depending on the job, you may need an inspection or certification afterwards. In some countries, you can do the work yourself, but you may need a permit or have to meet certain requirements to show that you're competent to do it. And then there are countries like Germany or Australia where electrical work is generally restricted to licensed electricians, so as a homeowner, you can't do much yourself. So check the rules where you live before you start. And third, you need to be reasonably comfortable with tools. If you never held a screwdriver before, starting with a breaker panel probably isn't the best place to learn. You can start with replacing a light bulb or making pallet furniture. The purpose of this video isn't to explain how a breaker panel works or go through all the basics of wiring one. I've already covered that in my 2 previous videos. This time, I'm wiring a small panel from scratch again, but the focus is on the practical side. How to route and organize the wires, how to make good connections, and the little things that makes a panel cleaner, easier to troubleshoot, and easier to work on later. I've also seen some comments on my previous videos and discussions online about things like cable grouping, usage of zip ties, connectors, and other equipment, so I'll touch on those subjects as we go. So let's build this panel and go through it step by step. I'll move this equipment out of the way for now. So here's our scenario. We're fitting a secondary panel. The power is coming from the main panel. We have a supply cable and 6 outgoing circuits, all installed in trunking, and we're fitting a surface mounted panel. So this is a panel, this is a cover, and this is a door. This particular panel can be fitted directly to the wall, or it can be installed on a thing called a GTL. A GTL is a French thing. It's basically a full height service space, a big piece of trunking that you fix to the wall. You bring your cables from above and below, and you clip your panel to it. I have a piece here. You fix this to the wall, and then you fix your panel to it. We don't need one here, as we only have a few cables, so this trunking is more than enough. I could have actually fitted all the cables into one, but you should never fill the trunking or any conduit with cables fully. This panel can be also fitted with a backplate, like Ron sells it as an accessory, but it's not required for this particular type of installation. Fix these pivoting pieces and lock them. They're useful for adjustment later. We center it. 25, 12.5, and this is 12, so 6.25 on each side. Mark. I don't actually have to mark it because I'm screwing this directly to the OSB, which is behind this plasterboard. So this plasterboard is fixed directly to the OSB, so I'm just going to use long screws. So when you do your wiring and you bring your cables to the panel, you should always leave plenty of extra length. Always leave more than you think. Half a meter, even meter. You don't want to extend the cables inside the panel. Label your cables accordingly. I prefer writing an actual circuit rather than simply putting a number on it. The reason is that during the installation stage, I don't always know exactly what the final arrangement of the panel will be. Sometimes a circuit gets added or moved around. Connect the supply cable last. So you do your wiring, you install your sockets, switches, lights, appliances, you wire your panel, and then you connect it to the main panel. That way you can do all the work with the supply safely disconnected and out of the way. Here I don't have anything connected as this is for demonstration purposes only. Now I'll remove the DIN rail and strip the outer insulation from the cables. For the larger supply cable, I'm using this type of a rotary cable stripper. You need to be quite careful with these, as on some cable, like on this one, there is nothing in between the outer sheet and insulation around the conductors. So don't set the tool too deep. Make a small test cut first. I'll remove this one too for now. Put it around, rotate. Peel the outer insulation. No damage, good. For these smaller cables, I can use this type of a cable stripper. We just wrap it around the cable, cut, and pull. Now as I'm stripping the cables, I'm also removing this temporary circuit identification. So by this stage, you should prepare your circuit schedule so you can number individual conductors by numbers. That's how I do. I just gotta find it. There it is, 1 washing machine, 2 dryers, sockets, shutters, ventilation, lights, and this is a pulse control for lights, and this is an RCD. So the dryer that I've just stripped, number 2, I use a fine tip marker and just write 2 on each conductor. Fine tip permanent marker. You can also use marker and white tape and put it around the conductors. Check if it's getting erased. Doesn't, good. And this is lights plus pulse control. Now I'll start with the earth conductors. On a small panel like this, space is limited, so good routing makes a big difference. Gloves. I normally start with the largest conductor, I supply earth, and work around it. I go down the panel until about here, back up. This leaves me plenty of extra length for servicing later. I make the bends gradually. And I try to make a conductor follow a natural path. Now when it can go into the terminal pretty much on its own, I tighten it. And we'll come back to tightening properly when we get to the breakers. I'll do the same with the remaining earth conductors. I follow the path of a supply earth, so it's neat and I have plenty of extra length. Now I'll bring them together with a couple of cable ties just to keep everything organized. And this is where you'll sometimes hear people mention grouping factor. Grouping conductors together can affect their ability to dissipate heat, and we'll come back to that in more detail when I install live and neutral conductors, because that's where it becomes particularly relevant. For now, the important thing is not to create unnecessarily tight bundles, so don't over-tighten the cable ties. They're only supposed to hold the wires together neatly in place, not to squeeze them together. Now I'll fold them all equally and cut them straight. This is number 1. Just rewrite the number. Okay, rewrite the number. Now I know where I'm supposed to put the numbers. Anyway, these are all 1.5 and 2.5 millimeters square, so just stab them here in these automatic terminals. And make sure they don't pull out, because that can happen with automatic terminals. It doesn't have to be perfect, but it should be neat enough for troubleshooting and servicing later. I put these little plastic labels because why not? I have them. Labeling earth wires isn't always essential as they're all connected together, but it can still be useful for troubleshooting. It can save you a lot of time later. Outgoing circuits down, supply cable up. That's how we'll connect our protective devices. And now I'll clip the DIN rail back and install our protective devices. This went too far. I need to put it back like this. For this panel, I have 6 outgoing circuits with 1 RCD upstream of the circuit breakers. The RCD provides residual current protection, while the MCBs breakers provide overcurrent protection. You might see a different arrangement in other countries and types of installation. For example, you could have all RCBOs. This one follows French rules for this particular type of installation. And I've also added this pulse control module for lights. It's like a conductor. I did a very similar panel recently for a small extension, so this is basically a copy of it. And when you're building a panel, make sure the equipment you're using is actually compatible. You don't necessarily have to use everything from the same manufacturer, but personally I like to stick with one brand whenever possible. It just makes things easier. Now I'll connect the incoming supply. This Legrand 63 amps RCD is designed to be supplied by a comb. So you can't physically insert this thick supply cable into the input terminals. If you have several rows, you can use a vertical comb and connect your supply to any of the rows. I'm only feeding one row, so I'm using a connector, which is basically a short section of the same vertical comb. I've seen comments online saying that this creates an extra connection point and therefore another potential heating point. That's true, but this is how the manufacturer has designed this RCD to be supplied. The connector is a proper accessory for this purpose, so if you're using this system, this is simply how you connect the supply. Now remove this once again and route these supply wires properly. Put your gloves, put your gloves. I just made a small break from recording, that's why I forgot to put my gloves back. I'll fix the connector first because it's easier. Too long. See, there's no insulation trapped and there's no exposed copper. Just take your time with this and check the connections again. Now when the supply is connected, I can install phase and neutral combs for the outgoing devices. These are 1P plus N breakers. So both phase and neutral are connected through the breakers. I'm using a universal phase and neutral comb here. So one side is marked for phase, one for neutral, they're symmetrical. Some manufacturers have their own specific comb systems, so always make sure the comb you're using is compatible with the equipment. Start with the neutral comb because it's behind. I want my cut side to go to the left here where the RCD is. I just find it neater like that. So I'll flip the comb and then measure. So I don't need it for this, but I can still keep an extra piece of comb. So I'll cut it up to here. Cut in the middle first. Then I want extra insulation so there's no exposed copper sticking. Pull the insulation. Cut it flush. Slide. Make it nice. Okay. Then I insert it. But first I want to insulate this copper part here. Take a piece of shrinking tube. cut a bit longer, half like this. I'm just going to use a lighter here, but you should use a heat gun. I just can't be bothered to get it from the garage. That's good. Oh, nice. There you go. Do the same with the face comb. Now we're getting to one of the most important parts, making the connections properly. I've already made some connections, but now is definitely the time to explain it. You want the connection tight enough to make good electrical and mechanical contact, but you don't want to over tighten it and damage the terminal. Just good and tight. You don't want your wires to pull sideways on the terminal when you unscrew them. You want them to naturally fall back into the terminal. Some manufacturers give you a specific torque settings. If they do, and if you have a torque screwdriver, follow it. Use a proper screwdriver head. This is a posi drive screwdriver, PZ2, and it fits perfectly into these terminals. This one is even better. It's a dedicated head for these protective devices terminals. And this is an electric screwdriver. This speeds things up a bit. What I personally do for the initial tightening, I'm using an impact screwdriver with the same dedicated head. But if you're not comfortable using one, just use a normal screwdriver. I'm not using the impact driver for the final tightening. It's very easy to over tighten and damage the equipment. And I start with first and last connection on the comb. Enough. Same with the face comb. The reason is, if you do them all in sequence, the breakers might twist on one side and it's difficult to put a cover later. The important thing is not to make the screws as tight as possible, just make a proper, secure connection. Now it's time to connect the outgoing live and neutral conductors. This is where you can really make a panel look either clean or messy. I can still move this to have a bit more space. I like to route them together, well, lives and neutrals a bit separate until about here, middle of the panel, following a consistent path, and then route each one to its own breaker. This again leaves us enough extra length, and I'm not trying to make every wire perfectly straight. A panel that looks perfect today but leaves you with no usable length when you need to do some work on 5 years later isn't necessarily a better one. I'll bring these connectors together with a few cable ties. Don't cut the wires. Okay, so we're back to the grouping factor discussion. When you group current carrying conductors together, they can't dissipate the heat as easily. The more conductors you put into one tight bundle, the more this can become a factor. But there is a difference between understanding that principle and turning it into an absolute rule, like never group more than 5 conductors together. You have to look at the actual installation, how many conductors are grouped, how heavily they're loaded, the length they're grouped together, and how they're installed. And there are formulas and calculations for this which are often done for larger commercial and industrial panels. Here we're talking about a small residential panel with a handful of relatively short conductors. I'm using a few loose cable ties simply to keep the wiring organized. So yes, grouping matters, but grouping matters doesn't mean never make your wiring neat. Use sensible routing, avoid unnecessarily large bundles, and don't over tighten the cable ties. Now since we secured them, I left extra length, I'll measure and connect one by one. bit too loose. By the way, this is one of the best wire strippers on the market, but it still struggles with this insulation. It's just a cable like that, just manufacturer. The conductor should enter the terminal naturally without being under tension or pulling sideways on the connection. Then I tighten the connection firmly. And I'll repeat the same process for the rest of the circuits. See how slowly I'm doing it. You can use any method of stripping wire you're comfortable with. Once everything is connected, I like to go through the panel one more time. I'll make sure that the conductors are fully inserted. This one is just a bit too long. Now I'll check if all the screws are tightened. That's the most important part. Yeah. So I don't press too much and the screwdriver slips automatically. Put these labels. Once I'm happy with everything, we can finish the panel with the cover, labels, and the door. With the trunking cover first. Now I'll fit the cover. I already cut it. I've cut it off camera. There's no point showing this, and this video is getting a bit too long. So you just fit it. Good enough. I won't fit these two because I'll put my door later and this goes on the door. Now this paper is for the labels. I'll make them using Legrand software, then print them on A4 paper, cut them and glue them on this. There are also dedicated label printers for fuse boards, but you don't need anything fancy. You can write them by hand. The important thing is that they're clear and durable. Now I'll put a cover on unused modules here. I already cut it 4 modules. These breakers and other equipment, they also come with their own label holders. And the panel comes with small labels to insert. Which I find useful because you can still identify the circuit once the main cover is removed. Now the only thing that's left is to fit the cover. I put my gloves again because I don't want my fingerprints everywhere on this. Normally they just click. And then this goes here, so you can shut the door. And then you put two other screws. They come with a panel. The door is sold separately. So that's the finished panel. This video wasn't really about how a breaker panel works. It was about the little things that make the difference between simply having all the wires connected and having a panel that is safe, clean, logical, and easy to troubleshoot. And hopefully some of these points that we've talked about make a little more sense now. The electrical work should be taken seriously, but don't overcomplicate things either. The goal should be simple: follow the applicable rules, follow the manufacturer's instructions, make good connections, and build a panel in a way that the next person can easily understand and work on it. Okay, so that's enough breaker panels for now. Next, we're going back to the basics: electrical resistance and how it relates to voltage and current. It's one of those fundamentals that make you really understand how electricity works, so you don't want to miss that one. And if you found this video useful, like and subscribe, hype, whatever they have now, and see you soon.